So here we have our first question, question 1, where we are given two coordinates A and B, where A is point -3, 2, and B is point 15, -8. And secondly, we are given the point N, which is the midpoint of line segment AB, as well as our final piece of information, which is line L, which is perpendicular to the line segment AB and intersects at the midpoint N. So we're first asked to find the coordinate N, which is the midpoint of this line segment, and we can use the coordinate of the midpoint of a line segment equation, which is simply taking the average of each of our coordinates, respectively, x, y, and z. Here we only have two coordinates, though. So we begin by finding the midpoint of x and y by substituting our x values into the first part of the equation and our y values into the second part. So first we have -3 plus 15. Okay. And we divide that by 2. And then we add our y coordinates and take their average, which is 2 plus -8 divided by 2. So we then continue to do our maths on this, and we find that our x coordinate then becomes 12 over 2, and our y coordinate becomes 6 over 2. We can further simplify this because simple numbers are always better than fractions, and we get 6 and -3. Apologies, this was negative here. Okay, so that's the first part of our question. We find that our midpoint, the coordinates of our midpoint, are 6 and -3. Okay, so this will be our midpoint, N. And secondly, we are now asked to find the slope of L, where L is at the midpoint N and it is perpendicular to the line segment we're given. Okay, so what we can do is find the slope of the line segment AB and find the negative reciprocal to find the slope of L, since it is perpendicular. So to find the slope of our line segment AB, we will use the gradient formula, where m, which is the slope, is equal to our second y coordinate minus our first y coordinate, which is the difference in y, and it is divided by the difference in x. So we use this gradient formula and we substitute our values in. Okay, so this is question 1. Now for question 2, we find the slope, where m is equal to y2, which is -8, minus y1, which is 2, and it is divided by the change in x, which will be 15 minus -3. So we then simplify this to get our slope for the first line segment AB, which is -10 over 18. And we can further simplify it so that it becomes -5 over 9. So as we mentioned before, we're asked to find the slope of line L, which is perpendicular to our line AB. So what we do for the slope of line L, we take the negative reciprocal of the line AB, of the slope of line AB, so that it becomes 9, positive 9 over 5. Okay? So now, for our final question, we are asked to find the equation for line L. And we can do this as we have the coordinate n, where line L intersects, and we have the slope. So we will be using the equation of a straight line, where we want to find the equation of line L in the form of y equals mx plus c, which is written below, but we can do this by using the point slope form of an equation, okay? And we can see that right here, where we have some coordinate y minus our coordinate y1, which is equated to the slope m multiplied by some coordinate x minus our coordinate x1, okay? So we will substitute our two coordinates of the normal into this equation for y1 and x1. So now solving for, whoops, I should have used blue, but solving for question number 3, we will use the point slope form of an equation where we have y minus y1, which is negative 3, equal to our slope, 9 over 5, multiplied by x minus x1, which is 6. Okay? Now we will distribute this fraction into our brackets so that we get y plus 3 equal to 9 over 5x, okay, minus 54 over 5. And then we will collect like terms, so we will be collecting this constant and find that our equation will become y is equal to 9 over 5x minus 69 over 5. Okay. And now, as you can see, we have our formula in the form of y equals m 9 over 5x plus b, where b is negative 69 over 5.